Hello, in this video, we're going to talk about variation in mathematics. So let's get started. So I'm going to talk about what variation is and we'll look at the various types of variation and so on. So let's start with variation. What really does variation mean? Variation comes to play when you try to compare two or more variables. That is, when you try to see how one variable affects one or more other variable, then you are going to be talking about variation. And variation is very critical in the world of science and also in math, especially when you want to build relationship between uh, two or more variables. You want to show how one variable can be obtained from another variable. Now, that's what variation entails. In fact, as the word implies variation, it comes from the word vary. That is, how does one variable vary with the other variable? So let me just give you this illustration. So let's say you have a particular, let's say we have a circle, right? And you have this circle. Just don't mind the it's not perfect. It doesn't look like perfect circle, but don't mind. Okay, so let's say you have these two circles. This circle A and this circle B, right? Now they have radius. Both of them they have radius. This is the radius of the circles R, and this is the radius of this circle R. Now, if I ask you what's the perimeter of this circle, for the first one, we know perimeter of a circle can be determined by something like this. P equals 2 pi r. But there's something you should observe here. The perimeter of a circle is actually the distance taken to go round, right? If you look at this, the distance it will take you to go round this smaller circle is shorter or smaller than the distance around this bigger circle. So what we can say is that the perimeter of any circle varies with respect to the radius. In other words, the perimeter of a circle is not fixed. The actual value of that perimeter is determined by the radius of the circle. So the bigger the radius, the bigger the perimeter, the smaller the radius, the smaller the distance around the circle. Now, what we can deduce from this statement is that we can say that there is a variation between P and R. In other words, P varies with R. In other words, P is determined by the value of R. Now, this is just an illustration to let you understand what variation is all about. It tells you how one variable is determined by another variable, and that's basically what we're going to study in this video. So now, what are the various ways by which two or more variables can affect themselves? So in the case of this perimeter, for instance, we know that if we increase the value of the radius, the value of the perimeter will increase proportionally. So there is a particular name we call this kind of variation, where as one increases, the other one increases proportionally. So in this kind of situation, we call this direct variation. So we're going to study other type of variation. So let's start with direct variation, then we'll move into other types of variation. So let's take a look. So let's take a look at direct variation. Direct variation deals with cases where you have two or more variables, or you have two variables connected in such a way that as one of them increases, the other one increases proportionally. So proportionally implies that the ratio between them is kept constant. So let's look at this kind of situation. Let's look at this example, then we talk more about it. So I'm going to explain how you interpret questions related to direct variation. And I'm also going to explain some of the notation you should take note of. So let's take a look at this example. Here we have W varies directly as U. If W is equal to 5, when U equals 3, find U when W is equal to 2 over 7. So first, let's try to understand how to interpret a question like this. W varies directly as U. So in variation, there's something called the relationship. You could be asked to find the relationship. Find the relationship between the variables. Between the variables. Then you could be asked to determine the formula. The formula between the variables. Now these two are slightly different. Now when you're asked to look for the relationship between the variables, they just want you to interpret the question literally and not go beyond that. But when you're asked to look for the formula, you're expected to look for what we know as constant. So I'm going to explain that using this example. So now, let's say you are asked to look for the relationship between these variables for this question. So how do you go about it? What you expect to do is to interpret it. So let's interpret this question. W varies directly. So this is how you represent this mathematically. W varies directly as U. So this symbol represents varies. Represent varies, or it's a sign of proportionality, or a symbol of proportionality. So what this means is you're not going to use equal to indicate how one thing varies with another. You just use this symbol which represents varies, or it's also a sign or symbol of proportionality. So this is how you interpret a direct variation. You just say W varies directly as U, and that's it. Now you can turn this relationship into a formula. Under variation, to turn a relationship into a formula, you add or you attach what is known as constant of proportionality. So what this means is, if I want to look for the formula this time around, so this is the relationship, right? Then to get the formula, you say W equals, you change this proportional sign to equal to K times U, where K is a constant, or the constant of proportionality. So now, what the constant does is it turns the the relationship into a formula. So that's what the constant does. So you may be asking, why do we add constant? So this is why we add constant. So let me use that example we used in the previous case where we talked about circle. If I say that the perimeter of a circle varies with the radius, right? Now this is a relationship. This does not give me the exact formula. This just tells me that, well, if you want to get the perimeter, you can get it if you know the radius. But it doesn't tell me exactly the formula to calculate the perimeter given the radius. So to get an exact formula, you need to go beyond this relationship. And that means you need to determine the exact constant you must multiply to the radius to get the perimeter. And in this case, I will just simply say P equals KR. So this tells me the exact formula for calculating the perimeter of a circle given the radius. But then, to get the value of K, you need more information. So that's why in variation, to get the value of K, they tell you more. More means they will tell you the value of the perimeter when the radius is something. They will tell you another value of, they will just tell you those. And with that, you can get the constant. But then, let's now look at the perimeter of a circle closely. We know that the perimeter of a circle is 2 pi r. So what this means is this constant must be equal to this too. So what this means is this constant is equal to this too. So K is equal to 2 pi. And you know, 2 pi is a constant. Constant means it doesn't change whether r is getting bigger or smaller. It's just a fixed number, right? So that is what we mean by constant. It's a value that does not change in a formula. It's fixed irrespective of what the variables values are, right? So this is how this is how we determine the relationship, and this is how we formulate the formula within for a variation, for a problem that has to do with variation. So now let's use this idea to answer the question that we have here. So let's recap what we have. W varies directly as U. To show something varies directly, just say W varies as U. There's nothing else. Then to turn this into a formula, you just add a constant, right? In this case, K is the constant. And once you multiply by a constant, it becomes a formula. Now, the question now is, we should find the value of U when W is 2/7. But before we can look for that, you need to get the next step in variation. Whenever you're asked to find one or two things, is to find the constant. Find the value of the constant. The value of the constant K. So how do you do that? Well, you can do that by making K the subject of the formula. So you can do that by saying, if I have W equals KU, then K is equal to W over U, if you divide both sides by U. So the constant is what we have as W divided by U. And that is what direct proportion variation means. Direct variation means the ratio between the two variables must be equal to a constant. So that is what direct variation even implies, that when you take the ratio between those two things you are comparing, it must be a fixed number, which is the constant. So how do we get a constant? So just look at the information given. W is 5 when U is 3. So K is what? When W is 5, U is 3. So it means the value of K is equal to 5 divided by 3. So that is the value of K. So if you plug this K back into the formula, then our formula now becomes 5/3U. So this is now the final formula after figuring out the value of K. Now that you've gotten the exact formula, this is now the formula you use for subsequent calculation. Now, they ask us to look for the value of U when W is 2/7. So when W is equal to 2/7, find U. So how do you go about that? You just plug in the value of W here. So it becomes 2/7 equals 5/3U, right? Then the next thing we want to do is to solve for U. So what we want to do is to multiply both. You can cross multiply. So you can just take this. Basically, this is what we have. This is 5U/3. So you can cross multiply, and that will give you 7 times 5U. That will give you 35U. Then 2 times 3. That will give you 6. So U is equal to 6/35. So this is the value of U when W is 2/7. So this is how you determine any value within a direct variation when it has to do with direct variation. So let me just recap the steps. The first thing you want to do is to express the relationship, which is this, right? The next thing you want to do is to express the formula in terms of the constant, which is this. Then the next thing is to find the value of K. What's the value of that constant? And to look for the value of that constant, just take the ratio between W and U. That becomes the value of K. And then you substitute the values into that formula. So just take your W as 5 in this case and U as 3, and that gives you the constant. Now that you've gotten the constant, return the constant back into the formula. If you do that, that will give you this formula, which is 5/3U. And this becomes the final formula. This is the formula that has the constant determined, right? Now that you've gotten this, you can use this formula to get any value. So from this formula, let me tell you, look for the value of W when U is this, or look for the value of U when the W is known. So that is the way you go about solving questions related to variation, to direct variation. So now let's talk about the next type of variation, which is inverse variation. Now let's talk about inverse variation. Inverse variation is more or less like the reverse of direct variation. So it's the same procedure, but the difference is the way you express the relationship. So now let's look at this example. Y varies inversely as x. So how do you express that? So when you are told something varies inversely, so what you are supposed to do is take that y, you add the sign of proportionality, right? Then inversely means you take 1 over that other variable. So in this case, the other variable is x. So if y varies inversely as x, then what that means is y is proportional to 1 over x. So that's basically what it implies. So this is the relationship. So this is how you interpret inverse relationship. Now, the next thing you want to do is to turn this into a formula. And how do you do that? You just say y equals k times 1 over x, which is k over x, right? So this is now the formula for this particular problem. So you just multiply by k and you turn that into a formula. So the next thing you want to do is to find the value of k, right? For an inverse variation, the value of k is always determined by multiplying those variables you are dealing with. So making k the subject means xy. So the value of k in the case of inverse variation is the product of the two variables. So what this implies also is that when you say two things are inversely related or they vary inversely, what it means is their product will be equal to a constant number. That's what it means. Okay, now that we've gotten a way to represent the constant, the next thing is to find that value of that constant. To find the value of the constant, you need to know, you need to have some information about the x and y. And here we are given that information. We're told that y is 4 when x is 1 over 2. So what this means is k is equal to 1 over 2 times 4, which is equal to 2, right? Now that you've gotten your constant, you plug this constant back to the formula, which means y equals 2 over x. So this is the exact formula connecting x and y. So this is the formula connecting. So with this formula, I can tell the value of y, given that I know x. And I can tell the value of x, given that I know y. So now the question says we should find x when y equals 10. So how do you go about it? So what is x when y equals 10? Just plug in the value of 10 and look for x. So what that means is you just say 10 equals 2 over x. Then if you cross multiply, 10x equals 2, and x equals 2 over 10, which is equal to 1 over 5. So the value of x is 1 over 5 when y is 10. So another thing to mention is this. When it says two things are inversely related, what it means literally is as one of them goes up, the other one goes down. So an example is this. So let's say you have a car, right? You have a car. You have a car that is moving, right? A car that travels. And now this car moves from this point to this point. So it covers a distance of d, right? Now, for every distance it covers, the fuel level goes down. So let's say at this point, the fuel level, so let's say this is a fuel gauge, right? So let's say the fuel is at this point. By the time it gets to this point, the fuel level would have dropped to, let's say, this level. So you can see that as the distance goes up, as distance goes up, this is the fuel level, right? The fuel level, which is L, goes down. So in this kind of relationship where one goes up, the other one goes down, you call that inverse variation. So that's what it means literally. But in the case of direct, as one goes up, the other goes up too. So for example, in the case of the perimeter, if the radius goes up, the perimeter goes up. But in this case, if the car travels further, if the distance covered like if the higher the distance covered by the car, the lower the fuel level. So that's how you conceptualize inverse and direct variation. So let's talk about the next type of variation, which is joint variation. So what is joint variation? There are times where a particular variable is determined by more than one variable. So in such cases, you call that you refer to that as joint. So let me give an example. So let's say you have a cylinder, right? You have a cylinder, and This cylinder has a particular radius, R, the radius of the cross-sectional area, right? And it has a particular height. So let's say the height is H. Now, if I ask you what's the volume of this radius, how do you calculate the volume of this radius, right? So the volume of this radius, V, is not determined by just one variable. It's proportional. The volume of the radius is proportional to two things. It's proportional to the square of the radius and the height of the cylinder. So what this implies is this: the volume of a cylinder is determined by at least two variables. So two things are at play here. Then the second thing again is it is proportional to the square of this radius. That is the cross-sectional area, the radius of the cross-sectional area, and the height of that cylinder. So in this situation, you say V varies jointly as the square of the radius R and the height. So that's how you should imagine this. So when we talk about joint variation, we are dealing with a situation where a given variable is determined by two or more variables. So we call that joint variation. So the joint implies those two variables jointly determine another variable. That is radius and height jointly, that is together, they determine the value of the volume. So that is how that is what joint variation implies. Two or more variables jointly determining the value. So jointly also implies that they determine the value of the volume by either multiplication or division. So what that means is I could have a case where I have C over H, right? Maybe let's say Y is proportional to C over H. So this is also joint variation because you have this Y jointly determined by C over H. So when the relation between those two variables, when you are multiplying or dividing, and they are jointly telling you the value of a given variable, we call that joint variation. So this is just a very nice illustration of what joint variation is all about. So now let's use this idea to interpret this question before us. So the question says the weight W of a metal bar. So weight of a metal bar. So let's say you have this bar here, a metallic bar, right? And this metallic bar, you want to look for a relationship or a formula that can tell you the weight, given that you know the length and given that you know the square of its diameter d. Okay, in this case, we are dealing with this kind of bar. We are dealing with a bar that looks cylindrical, right? This is a metallic bar. So this is the length and this is the diameter, which is d. Diameter d. So the question says the weight W of a metal bar varies jointly as its length and the square of its diameter d. So this means the weight varies jointly as length and as d square. So this is how you express it. So when you see jointly, it means take the first variable, attach it to the second variable, either by multiplication or division. But note that you may need to divide. That is, sometimes it could be like this, but it could be like this if you are told that it is inversely proportional to the square of the diameter. But if you are not told that it is inverse, then you just multiply the two variables. But if otherwise, if you are told one of them is direct, the other one is inverse, then you divide instead of adding. So, but we are going to get to that. There's an example we're going to look at that may involve division. Okay, so let's this is the relationship. So what about the formula? How do you represent the formula? The same idea. So you just take W, equate it to K LD squared. So K is a constant. Once you add multiply by K, the constant goes away. I mean the sign of proportionality goes away, becomes a formula. So the next thing we want to do is to look for the value of K. If you make K the subject, we're going to get W divided by LD squared, right? So now let's look for the value of K. That's the next thing. To look for the value of K, you need information about the W, L, and D. So we have that information. If W equals 140, when D equals 4 and L equals 54. So what that means is to get the value of K, just plug in the value of W as 140, the value of D as 4 and L as 54. So this is 54 times 4. So if you simplify this, you're going to get K equals 35 over 54. So now that we've got the value of K, we can just plug in the value of K back into that formula, and that becomes W equals 35 over 54 times LD squared. So this becomes the formula. So now the question is find the formula which we've got, and this is the formula. But if you are told to find a relationship, this is just the relationship, then this is the final formula. Then you may be asked to look for the value of W given other values of L and D, but in this case, we are just okay with the formula. So let's talk about partial variation. Partial variation is a very interesting type of variation where a particular variable is determined by a constant partly and also partly determined by another constant, another variable. So let me give this illustration. So let's say you want to buy electricity. I'm talking about prepaid electricity, right? And you want to buy from an online vendor. What they will tell you is this. They will ask you for the amount you want to buy. So let's say you need a particular unit of electricity. So let's say I need a 500 units of electricity. The cost the amount I'm going to pay is partly determined by the units of electricity, right? And it's also determined by another value, which is known as the charge. So let's say, the transaction fee. So let's call this transaction fee T. So U is the unit of electricity that I want, unit of electricity, and T is the transaction fee. So this is common if you want to buy electricity from online vendors. They will tell you, okay, maybe they will charge you 100 naira for whatever, that's the amount that goes to them, right? Then they may now tell you that whatever unit you want to buy, they will multiply by a particular value. So let's say, for example, you want to buy, let's say, for example, 100 units of electricity. Let's say 100 units of electricity equals 2,000 naira, for instance. So it means what they will do is they will now say, okay, because this 100 units is equal to 2,000, it means one unit is equal to 20 naira, right? 20 naira. So it means for every unit of electricity, they will multiply by 20. So your real cost will now be what? 20 naira times the unit of electricity that you want to buy plus their transaction fee. So what they will charge you eventually is 20 times 500 plus their own transaction fee, and that gives you 10,100. 10,100. Yes. Okay, so now the question is, how can we turn this kind of problem into variation? So this kind of variation is known as partial variation. Partial in the sense that this cost that we're talking about partly varies with a constant T, which is a transaction fee, and partly varies with the unit of electricity. Now, to turn this into a formula that we can just plug and play, we remove this equality sign, we remove this proportionality sign and add equality sign. Then this constant remains plus another constant K times U. So this, our new constant, we multiply to the second variable T is a constant, which is a transaction fee. Constant implies that the company that is processing your transaction will not charge you more than 100 naira, no matter the unit of electricity you want. So they have a fixed transaction fee, which is a constant. So no matter the unit you are paying for, you are not going to spend. There's a constant fee that will be attached to it, which is the constant T, and that's the transaction fee. So in this kind of situation, we say that T is partly constant, that is, the cost is partly constant and partly varies with the unit of electricity you want to buy. So if you look at this formula with this example we just went through, you can guess that this K is equal to the 20 naira. So what that means is eventually the real formula we're going to use, or the companies we use in calculating the cost of electricity, will be 20 T plus 20U. So if you replace T with the transaction fee, it becomes T, it becomes 100 plus 20U. So if you plug in any unit of electricity you want here, that will tell you the total amount you are going to pay for your electricity. So this is just an illustration showing you what partial variation really means. It's just a kind of relationship where what you want to find, which is the cost, is equal to a constant plus another variable. You understand? So that is what partial variation entails. So let's interpret this problem with this explanation I've given so far. So x is partly constant. So what this means is x is partly constant, which is, we can call the constant C, right? And partly varies with y. So it varies with y partly. So this is the relationship. Now, before we dive too deep, so the next thing you want to do is to turn this into a formula, right? So that's the first. So that's what we're going to do. But we've answered the first question. The first question is find relation between x and y. So this is the relationship. But then to look for the value of x when y equals 4, we need to turn this into a formula. And to do that, you need to say x equals constant c plus ky. You need to add another constant. This constant is for this other variable y. Now, c is a constant, right? Then k is also a constant of proportionality. Okay, so now we've gotten the two constants and we've turned this into a formula. So how do you determine the two constants? Because in the case of partial variation, there are two unknowns or two constants you don't know. And that makes it a little bit more difficult than other type of variation, because here you need to look for two unknown values, C and K. And that's how it goes for all partial variation. You have to always look for two unknowns. And I'm referring to basic mathematics, although for very advanced concepts in math and science, you'll be dealing with much more variables. But in this simple case, you have two variables you have to look for, at least two. So now the question says find the relationship between x and y, which we've done. Then find x when y equals 4. But before we can look for x when y equals 4, we need to solve for these two unknowns, c and k, which will help us have the final formula. So now let's go about it this way. The first thing you should know about partial variation is you must be given two information for each unknown. In the case of direct variation, inverse variation, they just give you the value of x when y is known, and that's all. But in the case of partial variation, they must give you double values. So double value means you must know x1 and x2. You must know y1 and y2. So let me explain. So look at the question. The question says when y is equal to 3, x equals 7. And now told you again, when y is 6, x equals 9. So what that means is they must give you two values for x and two separate values for y. If you don't have these two values, if you just have one value of x and y, you can't solve for this, because you need two equations to look for two unknowns. That's why in all partial variation they tell you two things. They tell you when x is this, y is this. They also tell you when x is this, y is also that. So that you have two separate information to help you get the two unknowns. So let's interpret it. So when y is 3, x is 7. So what that means is x is 7 when y is 3. So you can say 7 equals c plus 3k using this formula, right? 7 equals c plus 3k. So the other information we know is that y is 6 when x is 9. So when x is 9, y is 6. So that's 6k. So if you, so this, you can see, you can rearrange this. That becomes c plus 3k equals 7. So you can take this as equation 1. Then c plus 6k equals 9. You can take this as equation 2. So now we want to look for the value of C and K. So this will always lead you to simultaneous equations. So take note, every partial variation where they want to look for the value of x when y is this, it will always lead you to simultaneous equation because you'll be looking for two unknowns, and that means two equations, and that means simultaneous equation. So now let's look for the value of C and K. So let's use elimination method here. So using elimination method, what we're going to do is we're going to subtract equation 1 from equation 2. In other words, we're going to say whatever we have in equation 2 minus whatever we have in equation 1. So let's do this. So c minus c is 0. So this is gone. ck, 6k minus 3k will give us 3k. And 9 minus 7 will give us 2. So k is equal to 2 over 3. So we need to look, we've gotten the value of k. So let's look for the value of c. So to get the value of c, we substitute k as 2 over 3 in equation 1. So if you do that, c plus 3 times 2 over 3 equals 7. So c plus 2, so 3 you cancel out 3, so equals 7. Then c equals 7 minus 2, c equals 5. So therefore we can say c equals to 5 and k equals 2 over 3. If you plug this constant into that formula, you are going to get x equals 5, which is c, then plus 2 over 3k. So this is now the final formula that connects x and k. So once you've gotten the final formula without the constants, so this is y, not k, this is y. So once you've gotten the final formula without the constants, the next thing to do is to answer the next question, which is find x when y equals 4. So to do that, you just say x equals 5 plus, just plug in the value of y as 4 right here, and then you solve for x. So this becomes 5 plus 8 over 3. So this becomes 15 plus 8 over 3, and that gives you 23 over 3, and that gives you 7 whole number 2 over 3 if you want to write that in mixed fraction. So this is how you interpret partial variation, and this is also how you solve questions related to partial variation. So this brings us to the end of variation. In the next video on variation, we'll be solving a lot of past questions related to variation.